Asteroids are not just fascinating space rocks, they are a very real threat to Earth. NASA's recent mission to strike one of these celestial bodies, part of the ongoing efforts to protect us, has been creating waves in both scientific communities and popular media. It's a thrilling development that highlights just how much we depend on technological innovation to safeguard our planet. In this video, we'll break down how asteroid impacts have shaped Earth's history, what happens when one of these space rocks comes too close, and the groundbreaking steps NASA is taking to protect us from potential asteroid disasters. How asteroid impacts have shaped Earth. Asteroid impacts aren't merely about destruction, in fact, they've played an unexpectedly massive role in Earth's formation and evolution. Let's rewind billions of years, back to when the solar system was still forming. Collisions between asteroids, comets, and protoplanets were a frequent occurrence. These celestial impacts were so significant that one of the most important events in our planet's history might have been caused by an asteroid collision. Scientists believe that a Mars-sized object, known as Theia, collided with a young Earth, and the debris from this cataclysmic crash eventually coalesced to form the Moon. Fascinating, right? Imagine our planet being struck by something that big, altering not only the course of Earth's development but also creating our Moon in the process. But that's not all. These impacts might have been key in bringing life, sustaining water to our planet. Early Earth was a molten, dry, inhospitable mess. Many scientists believe that icy comets and water-rich asteroids may have carried the precious liquid that eventually formed the oceans, setting the stage for life as we know it. If you're thinking about the oceans we swim in today, it's possible that some of their water originally came from these space-faring objects. However, not all asteroid impacts have been so helpful. Over the course of Earth's history, several mass extinction events have been linked to asteroid impacts, the most famous being the one that wiped out the dinosaurs. The larger the asteroid, the bigger the potential devastation, though such massive impacts are incredibly rare. But just how often do these impacts happen? Let's break it down. How often do asteroids hit Earth? There's an inverse relationship between the size of an asteroid and how often it strikes Earth. In simpler terms, smaller space rocks hit our planet all the time, while larger, more catastrophic impacts are much rarer. Every single day, approximately 25 million tiny meteors enter Earth's atmosphere. These are often no bigger than grains of sand or small pebbles, and most of them burn up in the atmosphere, creating those stunning streaks of light we love to call shooting stars. We see them almost every night, yet most are too small to be dangerous. Throughout Earth's 4.5 billion year history, asteroid impacts have been a key driver in shaping the planet. One of the most significant impact events occurred around 65 million years ago when a massive asteroid, around 10 to 15 kilometers wide, struck what is now the Yucatan Peninsula in Mexico. This event, known as the Chicxulub impact, is believed to have caused the mass extinction of the dinosaurs, along with many other species. The impact triggered massive wildfires, tsunamis, and a drastic change in Earth's climate, a nuclear winter effect that wiped out large portions of life. Another major impact happened about 4.5 billion years ago during the Hadean Eon when a Mars-sized body, named Theia, collided with the early Earth. This event, known as the Giant Impact, is thought to have led to the formation of the Moon from the debris ejected into space. The collision also marked a pivotal moment in the development of our planet and its relationship with the Moon. In more recent history, Earth has experienced smaller but still impactful events. The Tunguska event in 1908 saw an explosion of a meteoroid or comet over Siberia, flattening about 2,000 square kilometers of forest. While no one was killed, this event serves as a stark reminder of the potential danger posed by near-Earth objects. But let's put all of this into perspective. On any given day, The biggest meteor likely to hit Earth's atmosphere is about 40 centimeters across. It's not exactly big enough to destroy a city, but it's still a pretty impressive sight if you catch it in the sky. On a yearly basis, we might see a meteor about 4 meters in size. While still not catastrophic on a global scale, it could cause serious damage, especially if it explodes in the atmosphere. These events, though rare, do serve as a reminder that even small space rocks can pack a punch. Every century, a space rock around 20 meters in diameter, roughly the size of a house, is expected to hit Earth. While this size may not threaten global survival, it could still cause significant damage if it explodes midair, like the Tunguska event. However, it's the giant asteroids that truly get our attention. These massive objects, measuring over 10 kilometers wide, like the one that wiped out the dinosaurs, come around once every few million years. Thankfully, these colossal impacts are incredibly rare, and scientists are pretty confident that they've already identified all the large asteroids in our solar system that could pose a threat to Earth. But let's not get too comfortable. What happens when meteors survive? Not all space rocks burn up in Earth's atmosphere. Some make it all the way to the surface, and these survivors are called meteorites. Meteorites are typically larger objects that don't disintegrate completely during their fiery descent through the atmosphere. By the time they reach the ground, they are usually smaller than when they started, often about the size of a brick. These meteorites are treasures for scientists, offering a glimpse into the building blocks of our solar system. NASA's steps toward protection. So, what happens if a massive asteroid is heading our way? Could we stop it? NASA's DART, Double Asteroid Redirection Test, mission provides us with an answer. The goal isn't to blow up the asteroid, after all, that could create smaller, still dangerous fragments. Instead, scientists have devised a strategy to gently nudge the asteroid off its course. DART's mission targeted Dimorphos, a small asteroid that orbits a larger asteroid, Didymos. The spacecraft successfully altered the orbit of Dimorphos, proving that we can, in fact, change the trajectory of a space rock. This was a monumental step in planetary defense, showing that with enough time and preparation, we might be able to prevent an asteroid disaster. Technological advancements in asteroid detection and deflection in recent years, NASA and other space agencies have made significant strides in detecting and deflecting asteroids. The DART mission, launched in November 2021, used a kinetic impactor to alter the trajectory of Dimorphos. On September 26, 2022, DART crashed into Dimorphos, successfully changing its orbit around Didymos. This was humanity's first attempt to intentionally alter the motion of a celestial body, and it proved that we can indeed change an asteroid's path using current technology. Following DART's success, the European Space Agency launched its Hera mission in October 2024. Hera's goal is to study the Didymos system in greater detail, including examining the crater left by DART's impact and analyzing Dimorphos' internal structure. This will help scientists refine their understanding of asteroid composition and behavior, which is essential for future planetary defense strategies. Additionally, advancements in space telescopes and observatories have improved our ability to detect and monitor near-Earth objects, NEOs. Projects like Pan-STARRS and NASA's upcoming NEO Surveyor mission use infrared imaging to spot asteroids that are harder to detect, especially those that don't reflect much visible light. The ability to detect these objects early is crucial for mitigating the risks they pose. What if one is heading our way? What if scientists do spot an asteroid that is on a collision course with Earth? Well, that's when things get serious. There are many ideas for how we might deal with this kind of situation. Some propose using nuclear devices to blow up the asteroid, but this approach has its issues. If an asteroid were blown into smaller pieces, those fragments would still be headed toward Earth, just in a shotgun blast pattern. Another idea is the gravity tractor method, which involves sending a spacecraft to fly alongside the asteroid and use its gravitational pull to slowly alter its trajectory. This method is less flashy but is a long-term solution that requires a lot of time and advance notice to work effectively. The DART mission and the future of planetary defense. NASA's DART mission used a more direct and simple approach. The spacecraft, roughly the size of a refrigerator, slammed into Dimorphos at a speed of 6.6 kilometers per second, successfully changing its orbit. The mission's success was a huge leap forward in planetary defense, showing that with enough